Hello everyone. Today we are going to start a new journey on the monetary models with sticky prices and wages. This is basically the new Keynesian models, in contrast with the monetary models with flexible prices and wages in the previous chapter. To remind you where we are, let me show you this big picture again. Now we are standing at the monetary models with nominal friction, or sticky prices and wages. This is a defining feature of new classical models. In comparison, in the previous chapter, all the monetary models, including the RBC model and the Friedman-Lucas model, they are all monetary models without assuming nominal frictions. But other assumptions, including the consumer and firms' behavior, are exactly the same as the RBC model. That is, they follow the intra-temporal conditions and intertemporal conditions in the static decision and dynamic decisions. So today we have two learning objectives. The first one is to know where we are standing in the business cycle theory, and to know the intuition of the prevailing new Keynesian models with nominal frictions. And the second learning objective is the focus of this lecture. That is to know how to graphically derive the responses of the output market, input market, and money market in the new Keynesian model after a policy shock. And this policy shock is the monetary policy shock in the form of an interest rate change. Note that all the derivations of this semester will take the graphical form because the mathematical model is too complicated for you to solve. But please do bear in mind that the graphical derivation is just another equivalent way of looking at the mathematical models with equations. They are not different, they're just different ways of showing the same logic. So let's address the first learning objective to see where we are so that it can help you to understand why we have new Keynesian models. There are 5 influential business cycle models up to now. I mark them as A, B, C, D, and E. Okay, the first model we have encountered in the previous chapter is the RBC model augmented with money. Basically, it doesn't have to augment with money because RBC model itself is claimed to be able to explain the business cycle. So augmentation with money basically proved that. This is a model developed in the 1980s by Prescott and Kitland. The fundamental assumption of RBC model is that the market is perfect. Following this assumption, they derive that the money is neutral. So money can only affect the nominal side of the economy and has nothing to do with the real side of the economy. So the policy implication is that monetary policy is not important at all. The second model we covered in the previous chapter is the Friedman-Lucas model, or money surprise model. It is developed actually earlier than the RBC model by Friedman-Lucas in the 1960s and 70s. Their fundamental assumption is that the information is not perfect. Consumers have to form rational expectation about future price levels to make decisions in the labor market. And they cannot distinguish a shock from the real side and a shock from the nominal side. So the monetary policy is not neutral because central banks can issue some surprise money to affect people's decision-making in the labor market, at least in the short run. So the policy implication of the Friedman-Lucas model is that money is not neutral and monetary policy can affect people's decision. However, they do not encourage this because monetary policy can distort the market signal and confuses people. The third model is the coordination failure model, originally developed by Keynes in the 1930s and later on revived in 1980s. The key assumption of this model is the strategic complementarities. That means people tend to have a herding behavior. Translated into human language, it means the individual decision of investment depends on the decisions of other firms. If everyone else are investing, then you tend to invest as well. So booms tend to follow booms and recession tend to follow recessions. The conclusion of this model is that money is not neutral as well because a higher money supply can send a signal to the market to coordinate different firms' decisions to kick the economy out of the recession trap. So to these coordination failure modelers, monetary policy is essential because it can stabilize the economy. The fourth model, Model D, is the new monetarist model, which is developed in the 1980s. The key assumption of this model is the deficient financial liquidity, so it only applies to a scenario when you have a recession and when you have liquidity trap. In this case, monetary policy is also non-neutral because appropriate monetary policy can provide liquidity to the market with deficient financial liquidity. Note that Model C and Model D are not covered in details in this course, but the slides on these two models are provided on the website in case you are interested. The last model we are going to cover is the new Keynesian models, Model E, which are developed in the 1980s along with the new classical models. The key assumption of new classical models is the nominal friction, or sometimes we call it price rigidity or wage rigidity. They are the same thing. And the conclusion of new classical models is that money is non-neutral, and monetary policy can be essential for government to stabilize the economy. We can, of course, group these models by different criteria in different ways. If we classify these models in terms of the assumption of nominal friction, then A, B, C, and D belongs to the models without any nominal friction, and Model E, the new Keynesian models, belong to the model with nominal friction or price rigidity. If we classify these models in terms of the neutrality of money, then the new classical model, Model A, is neutral, and all the other models B, C, D, and E are all non-neutral. And in terms of the policy implication, Model A, B, and D do not think the government should intervene in the market with monetary policy, but Model C and E argues for an essential role of monetary policy in stabilizing the economy. And both models, the coordination failure model and the new Keynesian model, have a root in Keynes in the 1930s. Please note that in this module, for the exam purpose, you don't need to understand Model C and D. What we are going to test is only on A, B, and E. That is the RBC model, the Friedman-Lucas model, and the new Keynesian model. Therefore, to understand the new Keynesian model, let's look at the history of how Keynes' idea evolves over time. The original ideas of the Keynesian model is, of course, proposed by Keynes himself in 1936. His idea is then operationalized and popularized by Hicks in his IS and LM model developed in 1937. In the 1950s, after the Second World War, the new classical models are combined into the Keynesian models, which forms the new classical synthesis. Note that this new classical synthesis is not the same as our new classical here. The new classical we have discussed in the previous chapter is NEW. That new classical model is a school of thought after the 1970s. But what we have talked about here in the 1950s is NEO classical synthesis. The NEO classical is a school of thought starting from 1870, which is 100 years earlier than the NEW classical school of thought. Basically, everything we have learned today in economics belongs to NEO classical, while NEW classical in the 1970s is just a special school of thought in NEO classical. Even new Keynesian, NEW Keynesian, is also part of NEO classical school of thought. Anyway, in the 1960s, the Keynesian's idea is then put into empirical models, which is called the macroeconometric models. It has hundreds of equations to be estimated, and the policy making are relying on these macroeconometric models. All these models are called the old Keynesian models because they are based on the original work by Keynes in the 1936. Everything worked quite well after the Second World War up until 1970s. The Keynesian policy stopped working in the oil crisis. During this crisis, there is a stagflation. The monetary policy only raises the inflation without changing the output, which leads to the famous Lucas critique in 1976. It also leads to the rational expectations revolution, originally proposed by Muth in 1960s, but later on formalized by Lucas in 1972. It even leads to the fundamental revolution in macroeconomics in 1982 by Kitland and Prescott, who introduced the micro-foundation into macroeconomic models. And this is what we have been doing in the first semester and this semester. That is, all the macroeconomic relations has to be derived from a microeconomic principle, that is, optimization and equilibrium. As a response, the new Keynesian models actually provide a micro-foundation for the old Keynesian models without changing the key assumption of the Keynesian models, the price rigidity or nominal frictions. Now let's zoom in to focus on the new Keynesian models, and I will begin our discussion with the summary of the new Keynesian models. Again, I'll summarize the assumption, the conclusion, and the policy implication of new Keynesian models. The key assumption of the new Keynesian models is, of course, nominal friction, which means prices and wages are not flexible due to various reasons. There are 4 popular ways to operationalize this assumption. The first one is the manual cost model. In this kind of models, you do not want to change your price if the optimal price changes, because changing price itself is costly. You would only change your price when the optimal price is too different from the current price. The second type of new Keynesian models is bounded rationality. In these models, people do not even know what is the optimal price due to the cost of information. So you can't reset the price because you don't know what price to set. The third type of new Keynesian models is the staggering contract model, which is the most popular way in the mainstream new Keynesian models. And there are 2 types of staggering contract. One is developed by Taylor in 1980, and the other is Calvo contract developed in 1983. The Calvo contract is the working horse model by the Federal Reserve in the US and the Bank of England in the UK. The last type of new Keynesian models is the so-called sticky information model. These models assume that firms only collect information once in a while, so you won't update your optimal price until you recollect all the information about the market. No matter which way you choose to model the nominal friction, they all belong to the new Keynesian model umbrella. But different ways of modeling the nominal friction lead to different quantitative feature of the model. But which assumption is correct is an empirical question. You have to use the data to verify and falsify the assumptions. And the Calvo model wins this competition. Most new Keynesian models adopt the Calvo contract as the model of nominal friction. But no matter which model you choose to model the nominal friction, a common conclusion of all new Keynesian models is that markets do not clear, because the rigid price or wage cannot adjust freely to make the supply equal to demand when there are shocks. Therefore, money is not neutral, and the monetary policy can play an essential role in stabilizing the economy. Now let's elaborate the 3 components of the new Keynesian models. Let's start with the assumptions. The key assumption of new Keynesian models is, of course, nominal friction. Sometimes it is also called nominal rigidity or sticky prices or wages. They are the same thing. An important implication of this assumption is that when firms set their prices, they have to think about today and tomorrow. So the optimal price to set P star must be a weighted average of the flexible optimal prices in the future PM if they can reset the price freely. To make our discussion more illustrative, we only assume sticky prices in the output market in our model, but the complete new Keynesian model have both sticky prices and sticky wages in the input market. A hand-in-hand assumption of all new Keynesian models is monopolistic competition, because if we assume perfect competition like in the RBC model, then there is no pricing power of any firm. But if you assume nominal friction, then you have to assume a certain pricing power of each firm. So nominal friction and monopolistic competition are two assumptions of any new Keynesian models, and you can't have only one, you have to have both at the same time to ensure the logic consistency. The rest of the models, however, are exactly the same as the RBC model. That is, you have a micro foundation for both consumers and firms. So the intratemporal condition, intertemporal condition, and the Fisher equations we have derived in previous lectures still hold. In the summary, we mentioned there are 4 types of new Keynesian models of nominal friction. Actually, the first 2 models belong to the state-dependent models because the opportunity of resetting the price depends on the state of the economy. And the other 2 models are called time-dependent models because when you can reset the price depends on time. Let's take Mankiw 1985 model as the representative model of the manual cost model. As we mentioned, in this kind of models, price resetting is costly because you have to, for example, replacing the old menu by the new one, and you have to print all these things all over again. And it will be only reset when the benefit of resetting the price is big enough to cover the cost of resetting the prices. And let's take Akerlof and Yellen 1985 as the representative model of the bounded rationality model. They argue that not everyone is rational or smart enough to work out the optimal price, and this is what they called bounded rationality. As you can imagine, taking derivatives and solving equations is quite difficult, and you have to collect all the information. If you don't know how to do that, then you probably don't know how to calculate the optimal price. So if you are bounded in your rationality, then you won't be able to know where the optimal price is, and so you can't set the optimal price. And the limitation of your rationality will result in a band of inertia as shown in this graph. So only when the change of the state of the economy is so significant that even the bounded rationality person can notice the change of the optimal price, then a new price will be reset. Now let's turn to the time-dependent models, which assumes that when you can reset the price only depends on time. Let's use an illustrative metaphor to explain the difference between different types of time-dependent models. Let's take resetting price as getting your coffee. So under the flexible price model, it means you can set your price anytime you want. And it's like you can get your coffee without having to queue whenever you want to buy a coffee. But in Taylor model, you can only set the price every n periods. It's like every time you want to buy a coffee, there is always a queue with n people waiting for their coffee. And if you want to get your coffee, you have to wait n periods. And after getting the coffee, you will have to go to the last of the queue and wait for another n period to get your second coffee. The Carvel model, in contrast, means that every firm has the equal chance to reset their price. It is like every time you want to buy a coffee, only 1 out of n people can get their coffee. The rest of the queue will not have the coffee this period. And if you get the coffee this period, it doesn't mean you will have a less or higher chance to get coffee next period. Every period have to be re-queued. So if you are unlucky, You may have to wait many periods to get your coffee, and if you are extremely unlucky, you may never get your coffee. So there are so many ways to model the nominal friction. Which way is the best? Well, this is an empirical question because you can basically collect some micro data and estimate how firms actually reset their prices. In fact, maybe all 4 types of resetting price models exist in reality. But it is convenient to assume that a firm reserves an opportunity at random to change its prices, just like in Calvo pricing. Because according to the data shown here, which is actually from my own PhD thesis, there seems to be a 20% chance for firms to reset their prices. But these firms may be different in each period. So the empirical evidence supports the Calvo pricing. And that's why Calvo pricing is the most popular way of modeling nominal friction. Now let's look at how to analyze the effect of a monetary policy shock in a new Keynesian model. Note that this is just a quick run-through of the new Keynesian models. Don't worry if you feel confused or you didn't get every details of the analysis, because we are going to repeat this in the next lecture, and I will give you a more formal and systematic analysis. This is just a heads up for the analysis we are going to do in the next lecture. Let's assume there is a monetary policy shock in the form of a rise in interest rate. We will discuss the effect of this monetary policy shock in the labor market, output market, money market, and in the production function like before. And the analysis will make use of the intertemporal condition and the intratemporal condition, as well as the equilibrium conditions in the money market. So if I were you, I will rewrite all the conditions I just mentioned in a piece of paper, and that is what I suggest you to do in the exam, to get ready for the formal analysis of the model, because all the graphical shifts will correspond to a change in the equations. They are not different things. Again, the graphical analysis is just another way of looking at the change in the equations. In case you forget what are these equations, I'll repeat them. The intratemporal condition for the consumer is marginal rate of substitution between leisure and consumption equals to wage. And the intratemporal condition for the firm is the marginal product of labor is equal to wage. The two intratemporal conditions are linked by wage. The intertemporal condition for the consumer is marginal rate of substitution between today's consumption and tomorrow's consumption is equal to 1 plus R. And the intertemporal condition for the firm is 1 plus marginal product of capital minus depreciation is equal to 1 plus R. And note again, these two intertemporal conditions are linked by 1 plus R. In the money market, money supply is equal to money demand, and money demand is equal to price multiplied by the liquidity function, and liquidity function is a function of output and interest rate. The starting point of the analysis is a rise in interest rate. Let's assume the original level of interest rate is Rm, and the new higher interest rate is R star. Looking at the intratemporal conditions, intertemporal conditions, and the money equilibrium condition, a change in interest rate R will obviously affect the intertemporal condition, because the intertemporal conditions of the consumer and the firm are linked by 1 plus R. And R enters the money demand function through the liquidity demand L. Now let's start the analysis. A rise in interest rate R will make one side of the intertemporal conditions higher. So for the consumer, the marginal rate of substitution has to rise as well to restore the equation. And similarly for the firm, the marginal product of capital has to increase to restore the equation. To make this happen, we have to make use of the diminishing marginal rate of substitution and diminishing marginal product. So C has to decrease to make marginal rate of substitution to increase, and K has to decrease to make marginal product of capital to increase. To summarize, a rise in R will decrease consumption C and a decrease in capital stock. This conclusion is quite intuitive because when interest rate rises, that means the opportunity cost of consumption and investment will be higher because you could have saved the money into the bank and earned a higher interest. But that is not the end of the analysis, because a lower C and lower capital stock will also have an effect on the intratemporal condition. Since C appears in the marginal rate of substitution between leisure and consumption in the intratemporal condition for the consumer, and capital appears in the marginal product of labor in the intratemporal condition of the firm. Since both consumers and firms are price taker, so they won't have any control over the wage, the only thing they can do to maintain or restore the original equilibrium is to change their endogenous variables, for example, for the consumer, to cancel out the effect of a drop in C. The consumer has to drop its leisure, and the drop in leisure means a higher labor supply. So to summarize the overall effect of the rise in interest rate on the labor supply, it shifts the labor supply to the right. And on the other hand, a drop in capital stock has to be cancelled out by a proportionate drop in labor demand on the firm side according to the intratemporal condition of the firm. So to summarize the effect of a drop in interest rate on the labor demand is that the labor demand curve has to shift to the left. We have shown these two simultaneous effects on the labor market in the upper left graph. Note that we actually have done this analysis in the dynamic RBC model in the previous semester. So if you forgot this analysis, please do review the relevant chapter. So in the labor market, after this change, the new equilibrium wage drops, and there is a very small drop in equilibrium employment size N. Now let's look at the output market, which is very different from the RBC model analysis. Under the new Keynesian assumption of nominal friction, the output price cannot change in the short run. So a rise in interest rates from RM to R star will drive a gap between the supply and demand. In other words, there is an excessive supply between Y1 and Y star. In the short run Keynesian models, it is always assumed that the demand determines the supply. So how much is supplied depends on how much is demanded for. In this case, it means the final output is Y star. The gap between the original output Ym and the new output Y star is called output gap. Now let's turn to the last market, the money market. A rise in the interest rate will make the liquidity demand to decrease. But in the money market equilibrium condition, M equals to P multiplied by the liquidity demand. In the short run, the price level on the right-hand side is fixed. So to restore the equilibrium condition in the money market, money supply on the left-hand side of the equation has to adjust downward to cancel out the negative effect on the right-hand side due to the lower liquidity demand. And this effect is shown in the lower left diagram. And finally, the lower right diagram shows the effects on the production function. That is, a higher interest rate leads to a lower employment size and a lower output level. Now let's summarize everything we have done in the previous slides by human language. Under the key assumption of new Keynesian model, the sticky price fails to clear some markets, so there will be excess supply or excess demand in the short run. As a result, money and monetary policy are non-neutral. A rise or drop in interest rate can decrease or increase the output, and employment. As we mentioned earlier, the market clearing interest rate RM is referred to as the natural rate of interest in the New Keynesian literature, and the difference between the market clearing output YM and the actual level of output Y star is called the output gap. In the New Keynesian models, the market outcome is no longer Pareto efficient because the first fundamental theorem of welfare economics no longer holds. In the next model, we are going to see how to analyze the other shocks in this New Keynesian model. To summarize, this lecture relaxes the key assumption of the new classical RBC model, the flexible prices, and then discusses how to introduce nominal friction into the New Keynesian model. And we also see how to analyze the effects of monetary policy onto the real side of the economy. And we conclude that nominal friction enables the monetary policy to have non-neutral effects on the real side of the economy. Enjoy!